Now let's talk about the sorting sequences, right? Now, just like with the concatenation and the in-place concatenation, we saw that we have a two different way of sorting a mutable sequence. First, returning a new sorted sequence, and the second, the in-place sorting, which mutate the sequence itself, right? So first, now we'll talk about the sequence or the sorted functions. So for any iterable, we have this built-in sorted function, which will return the list containing the sorted element of the iterable. That means any iterable can be sorted. A element must be a pairwise comparable. First, like if you have the tuple, set, dictionary, any element that can be sorted using sorted functions, right? And all the element must be the comparable, then only it can compare based, and then based on that it will sort. It return the result always in the list. So even though if you have the tuple, it will return you the list only, and the original iterable is not mutated, so original value will still be there, right, as it is. That will not change. In addition, it also have the key parameter, which takes the function as an argument to compare the value, right? And it also have the reverse argument, which return the value in the, or which return the sorted value in the reverse order, right? Now first check that. Consider here we are creating a tuple, and now we are using a sorted functions to sort the tuple. By default it has sorted based on the natural number. It's easy. And remember, here you can see that we have got the list as an output. We can also sort non-sequence iterable. Here we have the set object. We can sort the set, and then in return we are getting the list as an output, right? Here we have got the sorted element. Now we can also sort the dictionary, but let's see, when we iterate a dictionary, what do we get? When we iterate a dictionary, we only get the key value. So the key is only iterable in the dictionary, right? So same thing will happen when you sort the dictionary. It will only sort the key. Like over here, we have the dictionary. When we apply the sorted of D, we'll get the key based on the number. We have got 1, 2, 3 as an output. But what if we want to sort a dictionary based on their values? So in this place, we can use the key argument to sort the element based on their values, right? We are going to specify the sorted function over here, right here. In this, like here we have this dictionary. Now in the sorted function, we are passing D, and then we are passing key. You see that key takes the function as an argument. Here we have created a lambda function which takes the key and get the values based on the key. This function is totally we have to create, right? So here, so each key, each iterable value will be taken. So what is iterable in this dictionary? The iterable is key. So it takes each key and then pass this to the dictionary D of k, and then it will get the values. So first it does is it apply the key. First it apply all the functions, and then based on these functions it will sort these elements. So we should get C, B and A because of the value we are seeing over here. So here when we run this, we should get C, B, A. Why? Because the 10 comes first, then 50 and then 100, because this sorting is happening based on their values, right? Now consider this. Here we have the here we have the tuple, right? And it is a string of tuple. When we apply sorted, it has done sorting. But as we can see, the natural ordering of the strings are used over here, right? So A, B, then I, then L, this thing happened. But let's say that if you want to sort based on the length of the string, so what you can do is you can create a lambda function as well, or you can also create a own function. We have created a function called sort key, which takes the string and return the length of the string. That's it. And then we can pass this function over here as a key parameter. Now this will do sorting based on the function or based on the length of the string. You can see that, right? Now it is based on the length of the string. We can also, instead of this, we can also use a lambda function over here, which takes the string and get the length of the string. Here we can see that. Now you see these things. Here this late and bird all are having the equal length, right? So how this thing happening? So actually Python uses a special algorithm called tim sort. This sorting algorithm is named because this sorting algorithm is designed by the Tim Peter, who was the core Python developer, right? And because of that, now we are calling this sorting algorithm as a Tim sort, right? And it also called as stable sort algorithms, right? Now this means that the item with the equal sort key maintain their relative positions, right? And so consider that, like over here, we have this T over here. Now we are applying, now we are doing the sorting based on the length. Here you see that the length of all the value, all the elements are same. Now when we run this, what we are getting? We are getting the exact whatever the value we have. We are not applying any sorting, right? Now let's change the sequences. First we pass B, 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 then we C, then A, then E and D. Here we have changed the position, and again when we apply the sorting, there is no change. We can see it is still there. So it has maintained their relative positions, right? If the length of the values are same, it will not do sorting. It will maintain the same value, or it will like all the element will maintain their relative positions, right? And this is what happened over here. This was a tuple. When we applied sorting, first this has the 4 element, then late, and then the bird. So this will, so when we do the sorting over here, first A will come, then is, then this late, bird, and then parrot, because this is what the ordering is. Let's check that. Here we see that A is. Now again, here we are changing the relative position. First this bird and then late, and then when we sort it, we can see that this bird and late. So here this and this both are maintaining their relative positions. So now you know how this sorting happens, right? Now you can also sort the element which is not comparable. Like we have this complex number. Complex number is not comparable. We can see that we cannot compare it. We'll get the error. But we can do sorting here. Now what we can do is, now as we can see that, right, we do not have the ordering of the complex numbers, but we may want to sort the complex numbers based on the distance from their origins, right? Let's say that we have this tuple, list of tuple over here. Now we can easily calculate the distance from the origin of each complex number using absolute function. If we'll take absolute of 3 plus 4j, this will give you one number, which is the distance from their origins. Now we can use this absolute function to do the sorting. We can pass this absolute function to the key parameter, right? If I do so, now here we have sorted the complex numbers, but not based on their comparison, but based on their distance from their origins, right? We can also decide if you want to sort the element based on the imaginary component. We can take, here we have created lambda function and extracting the imaginary value. We can also do this. So first -3 is the first, then -2, then 0, plus 4, and plus 10, right? Now let's talk about the reverse sorting. We can also do the reverse sorting. For that, we have this reverse parameter in the sorted function. Consider this. Here we have the tuple. This is the sorting we are doing. Now when we say reverse is true, so this entire sequence will be in the reverse order. We can check that, right? You can also implement this by these functions by passing this minus length. But again, like this would be more useful and more readable. This is not very much readable. Now let's talk about the in-place sorting. So in-place sorting and sorting, both functions we do not have any differences in both functions. So in-place sorting will only mutate the original element or original data, but sorted function will not mutate the original data, but it will take that sequence data and convert it to a and like make a copy of that data and output in a list. But in place sorting is actually changing the exact position of the element inside a list again, but it will not create a list. So the memory address of the original value of the original sequence data will not change, right? But again, you can do this if you can like you can do the in place sorting if that object support or if that sequence data subject or supports. We know that the list support the in place sorting, right? Again, we use the same algorithm like tin sort algorithm over here as well. Now let's try to do this. Here we have again the tuple does not support the mutability, so so there is no sort method over here, so we have to keep that in mind, right? Now here we have this list. We can check the id of L, which is this. Now when we do the sorting, it will give me the new object, and then we can even check the exact this list, and then we can check the id of the list. So this list is still there, it is still intact, nothing happened to this original list, but the id is still the same. Id has also not changed, but sorted has given me the copy of new object, right? But if you do l.sort, which is the in place sorting, we can see that here we have this in the key parameter. We are passing that we want to sort based on the length, and then we are storing that output into the result. But what we have seen that this sort method does not return you any copy of element, so it will not return anything. So in the result there will be nothing. We can check that in the result we are getting none because it does not return anything. We can check the id of L. So id of L, this list and this list is still the same. Again, we are talking about the same list. But what we see is when we check the L, now this L itself has mutated. This is the output we are getting, but the original list was this, right? So the original position of the object have changed, right? But object itself has not changed. This is how a in-place sorting works. Now let's talk about sorting or the natural ordering for the custom classes. Again, we have already discussed, we have already like a kind of implemented less than greater than method, right? But again, here we just like as long as this less than and greater than method support, we can do the sorting for the custom class as well. Here we have created a class, we have the repr method, and now we are in the less than method. We can sort these based on the value. We are sorting based on the value, right? Here we are seeing that we have this multiple object of my class. Now when we apply this in a sorted functions, it will work because it has sorted based on the values. We can see that 10, 10, 20, 20, right? Now, in fact, we can also modify it slightly so that we can sort. So here, what is happening is it is calling this method every time. Here we have done some like here we have changed a version of this less than method, and here every time when the less than method will be called, it will print this functions, like it will print this, and then after it will return the sorting. So here what we're trying to do is we are just trying to understand that how less than function is being called. And as I have said, it calls every time when it sort the element. Let's run this. We have created the multiple object, and when we create a sorted of this list of the object, what we see is we can see that first it has called C1 is less than C2 or not. Then it is calling C3 is less than C2 or not. C3 is less than C1 or not. So it is trying to sort each and every element, and then based on that it is giving you the output. We are getting this result because of this print function, right? So this is it. This is how we know, like, so this is what we have understood about the sorting of the sequence, right? Thank you very much.